Alright, this is Chapter 4, Section 2, Angle Relationships and Triangles. By the end of the lesson, you should be able to do two things. One, find the measure of the interior and exterior angles. These are your new vocab words. The second thing you should be able to is to apply theorems about the interior and exterior angles. The application part is the hard part for you guys, so definitely pay close attention when we get there. The first theorem is the triangle sum theorem, and this theorem says that if you have the measure of angle A plus the measure of angle B plus the measure of angle C, you get 180 degrees. And I'll show you really quickly kind of how that works. So I have my triangle here. If I tear off this corner and this corner. So I tore off A and C, and I fit them right here next to angle B. You'll see that they're going to make a straight line right there. And all of you already know that a straight line is 180 degrees. So that's what this theorem is telling you. You also need to know that you're going to be able to make an auxiliary line. An auxiliary line is a line that you add yourself that's maybe not originally in the picture, but you can add it so that it can help you in proving whatever it is that you're being asked to prove. So here's your first example. It says, after an accident, the position of cars are measured by law enforcement to investigate the collision. Use the diagram drawn, this one here, from the information collected to find the measure of angle X, Y, Z. X, Y, Z is this angle here. So that's the one that we're going to find. The first thing we're going to do is we're going to use the triangle sum theorem, which tells me that the measure of angle XYZ plus the measure of angle YZX plus the measure of angle ZXY will add up to 180 degrees. I already know that this angle here is 40 degrees, right here, and this angle here is 62, right there. It's going to equal 180, and then this is the angle that I'm trying to find. So I'm just going to put an A because I labeled that A. The 40 plus the 62 gives me 102 equals 180. Subtract 102 from both sides. I get A equals 78 degrees, which means that the measure of angle XYZ is 78 degrees. You're also going to be learning corollaries in addition to the theorems that you're going to be learning, and a corollary is a theorem whose proof follows directly from another theorem. So you already know that all the angles in a triangle, if I add all of them up, it's going to add up to 180 degrees, and that's where these are derived from. So the first corollary is that if you have a triangle that is a right triangle, you see my right angle here, that the two other angles, so angle D and angle E in this case, if I were to add them together, I get 90. And that's because all three of them are going to add up to 180. The second one says that if I have an equiangular triangle, which means that all the angles are the same measure, that each one of these angles is going to equal 60. And again, that's because you already know that all of them equal 180. So these are the two, in addition to the other one, that you're going to be applying today. So here's our second example. It says one of the acute angles in a right triangle measures 2x degrees. What is the measure of the other acute angle? They don't have anything drawn here for you, so it's a good idea for you to draw it in yourself. This is my right triangle because they told me that it was right. And they told me that one of the measures, is going to be 2x degrees. Alright, so that tells me that, let me label these. We got A, B, and C. The measure of angle A plus the measure of angle B is going to equal to 90, and that's because the acute angles of a right triangle complementary. And these are the acute angles, and this is my right angle. So we already said that A was 2x plus the measure of angle B is going to be 90. Then I need to subtract my 2x from both sides. I can't combine these, so I'm just going to bring everything down. And my measure of angle B equals 90 minus 2x degrees. Here are some more definitions for you. Interior is the inside of your angles, or your triangle, so all of this stuff in here. And then exterior is all of the points outside. In for interior, X for outside. And we also have interior angles. So interior angles are formed by two sides of the triangle. So this side and this side form angle 3, which is interior. This side and this side form angle 1, which is interior. And this one form angle 2, which is interior. And exterior angles are formed by one side of the triangle and then an extension and an adjacent side. So this is one side of my triangle, and this side is being extended. So this angle 4, created by this side and this extension, is the exterior. You also have something called a remote interior angle. So all three of these are anterior angles, but angles 1 and 2 are the remote interior. So they are the ones on the opposite side of the exterior angle that you're looking at. So if we're talking about angle 4, the opposite side would be angle 1 and 2. Those are the remote interior. I believe this is the last theorem for this section. You have an exterior angle theorem. So this angle 4, which was your exterior angle, is going to equal the measures of 1 and 2. And if you think about the example that I showed when I was tearing the paper, if I tear off angle 1 and I tear off angle 2, and I stick both of these into this empty spot right here, they're going to make that 180 degree line. So 1 and 2 are going to be equal to this 4 section right here. Alright, your directions for this next example is to find the measure of angle B. Angle B is here. And if we talk about the exterior angle theorem, this exterior angle is going to be equal to the two remote interior angles. So I'm going to use that information to get my equation. So the measure of angle A plus the measure of angle B equals the measure of angle BCD. And then we're just going to substitute all of the values that we have. So A is 15, B is 2x plus 3, and BCD, which is the exterior angle, is 5x minus 60. On this side we're combining like terms, bringing down my 2x. 15 and 3 give me 18. Equals 5x minus 60. Then I'm going to add the 60 to both sides. Oops. And I'm going to subtract the 2x at the same time. These are a zero pair. These are a zero pair. 18 and 16. Oh, excuse me, 60. I don't know where that 16 came from. 60. 18 and 60 gives me 78. Equals 3x, divide both sides by 3, I get x equals 26. Now, if you were to give me 26 as your answer, it would be wrong, because your directions say that you need to find the measure of angle B, not x. So I have to go back to angle B. Angle B was 2x plus 3. But now I know that x is 26, so that's 2 times 26 plus 3, which gives me 55 degrees. Then 55 degrees would be your answer for the measure of angle B. Oh, I lied. This is the last theorem. Okay, so this one says that if you have two triangles where two of the angles are congruent, two sets of angles are congruent, then that means that the third one, the leftover angle, is also congruent to the other. Using that theorem that we just talked about, we need to find the measure of angle K and the measure of angle J. Now, some of you are going to have a hard time seeing this as two different triangles, so my advice, if that's difficult for you to do, is redraw them so that they are actually two separate triangles. And then you can fill in all the same information and all the same labels. And then you can actually look at them as two different ones. That way you don't get confused. So I'm going to use the third angles theorem, which tells me that if these two angles are congruent and these two angles are congruent, then these third angles must also be congruent. So that means that angle K should be congruent to the measure of angle J. And then I'm going to fill in those values. Oh, I said measure, didn't I? That's equal. Okay, so then I have 4y squared equals 6y squared minus 40. I subtract the 6y from both sides. That'll give me 2y squared equals a negative 40. Divide both sides by a negative 2. That'll give me y squared equals 20. And then I need to take the square, y squared. Take the square root of both sides, which means that the measure of angle K is, oh, you know what? I don't even need to take the square root of both sides because it says y squared. Measure of angle K is equal to 4 times y squared. We know that y squared is 20, so that's 4 times 20, which is 80 degrees. Don't forget to write your summary, and I would like you to try and have those 5 sentences. Hopefully you remember to write your essential question in the beginning because I forgot to remind you.